Welcome back. We're going to look at the second doctrine in this video segment, which is called shared ownership. Again, the documentation can be found here, and it is embodied by a new template, once again, called shared PTR. So we had unique PTRT, now we have shared PTRT. So let's take a look at what this is. And again, that's unique to C++, of course. So the documentation at the top of the web page we were just talking about here, right? Just at the top of this. Is telling us the following. An STD shared PTR is a smart pointer, so it's an object, once again, that retains shared ownership, well, we could have guessed, of an object through a pointer. Several shared PTR objects may own the same object. The object is destroyed and its memory is reclaimed when either of the two following conditions happen. So one of the bullets is enough. The last remaining shared PTR owning the object is destroyed. So you had a bunch. Then some disappeared. There is the last one, the survivor. When that one goes away, just like a unique PTR at that point, the shared resource goes. The second option is that the last remaining shared PTR owning the object is assigned another pointer via an assignment operator or a reset. So you forcefully modify the last reference, in which case the ownership is lost. So that's all the documentation says, and it probably is a little unclear as to what you're getting out of this. So let's take a look as to what's going on. So I'm going to try and illustrate a number of ideas. So those are the creation, the sharing, the destruction, and the assignment. So let's say that you have an object. And again, the object could be an integer, right? It could be anything you want. It could be an int, a float, a double, or a struct, or eventually a class, right? But you have an entity of some form. So here's an entity, and you allocate it, of course, on the heap using new. So you say new foo, whatever that might be, right? Oops, I didn't see I was writing in the text. Sorry, let's move a little bit. So you have an entity and you say new foo, right? With some arguments. So that gives you one such thing. Then what you get back normally out of this is just a pointer. Now we're going to create a shared pointer. And the shared pointer is that little guy again. It looks like a normal pointer. But there is a difference. Now what it will do is that it will point to another object, a tiny little guy here, that essentially has two attributes. It has the pointer that new has returned. So it points to this guy. And it has an integer that says how many people own him. And right now, because we just newed the guy, only one owner. That's all there is to it. Now if later on you take that guy P and you entertain the idea of doing, say, Z equal P. You do an assignment. What happens in that case? Well, you get a box called Z, and Z will actually also point up here, and that counter will be upgraded to a 2, because now there are two owners of that guy. They go through that in order to get to him, but there are two of them. The idea now is that if at some point in time Z points somewhere else, that is, we make Z point to another object, then I would have something like this, maybe like 17 references already to an object. And if I make Z point to there, this link goes, Z points here, and the 2 here gets crossed out, and I'm back to a 1. So as I actually create an object, I manufacture this and this. I make this guy point to the manager, so this is the manager. And the manager points to the thing being managed, so this is the managee, if there is such a word. So this is whatever gets being managed. And I have a reference counter here that counts how many owners of the manager exist. And that's the entire story. Now, if I want to share with such an assignment, which you can write like this now, what happens is you are basically updating the pointer, the manager reference counter gets updated, and we always know through the manager how many owners for that thing do exist. When the counter eventually dropped to 0, so imagine now that I assign and I say P is also pointing to that, then this would go away. The pointer would come here. That would become an 18. And at that point, this counter would drop from 1 down to 0. When the counter hits 0, then we know what happens. Boom, E goes away. Boom, E goes away. This entire thing is deallocated. So we lose the existence of that as a result of transferring ownership and making P refer to another shared object. So assignments are the ways to actually pass along and share ownership with somebody else. As a result of these assignments, some object may lose their last reference to something. And when that happens, here P was assigned, right? I did something like P equals Z in this case. So I made P be the same as Z, pointed here. And when I do that, the old thing that P was pointing to, if nobody points to that, well, that thing has nobody that cares about it. So therefore, the only thing it can do is go away and gets released. That's the entire idea behind this. So once again, there is a method get. And once again, I have to tell you, do not use get. Get is not there for you to use. It's just for legacy reason. If you want to pass a pointer to such a thing or such a thing to a library function that knows nothing about shared PTR, the only way to do that safely is to actually call get to get a raw C pointer and transfer ownership. Or at least pass along, share ownership with that library for a little while. But remember that the idea, once again, is that this is a very transient sharing. The library would not store that row pointer, would not keep this row pointer anywhere, and would not use that row pointer to deallocate the object, right? That would be a terrible idea. If it did, then the entire thing would be crashing down because you broke the abstraction. You're not supposed to call get. The moment you call get, you break the abstraction. So be careful about this. There is a second one, which is called use count. This one is purely informational. It cannot make any damages, and it's kind of neat because it returns the value of those counters. And you can therefore always, by taking a look at this, a peek at this, you can figure out how many owners are currently sharing me, how many references to me, the manager, are currently in existence. And that's great, and I will use it in the demo to actually illustrate the sharing mechanism. So that's the basic idea. I want now to actually show you a few pieces of code to illustrate what is going on, and in particular, illustrate what can go wrong. But this we'll do in the next video.